Okay, this video is going to deal with the relationship between potential and equilibrium constant. It does it through the Nernst equation. So the Nernst equation given below, E equal E naught minus 0.05916 log of Q all divided by N is what we're very familiar with. Now, this is Q represents a non-equilibrium and so in this case the reaction is going to go one way or the other. We don't know which way, but it's going to move. If it turns out that it's at equilibrium, then there's zero potential. E equals 0 at equilibrium. At equilibrium, at K or equilibrium, it has zero potential because it's at the chemical concentrations it needs to be at, and so the reaction will not move. And so you get 0 equal E naught minus 0.05916 over N log of K. The Q turns into K at equilibrium. Okay, and so what we end up then with E naught equal negative 0.05916 over N. Actually, it's positive. There was a sign change times the log of K. And you manipulate that, and you get K equal 10 to the N E naught over 0.05916. Okay, so let me demonstrate this to you. I'll do a reaction next, and we'll see how this works. This is the equation, but you can get at it if you can know the Nernst equation. All right. So here you have it. I've written a reaction that we're going to look at, and our two half reactions are aluminum, gives us aluminum plus 3 electrons. That's an anode. How do I know it's an anode? Well, it's oxidation. Losing electrons. All right, and so our redox potential is negative 0.1677 volts, and I'm combining it with the cathode, the reduction reaction right here of nickel hydroxide plus 2 electrons gives nickel plus 2 hydroxides. It's a cathode, and our E naught is negative 0.714 volts. This is our balanced reaction down here. 2 aluminum plus 3 nickel hydroxide give us 2 aluminum plus 3 nickel plus 6 OH minus. And E of the cell, which is equal to E naught of the reaction, is equal to, is equal to 0.963 volts. And so the reaction equilibrium will be, by our equation, 10 to KQ equal 10 to the N E naught of the reaction over 0.05916, which is equal to, you're going to be surprised by this, 10. The number of electrons transferred, you got to pay attention to that. Our cross multiplies 6 electrons times 0.963 divided by 0.05916, and when you do that math you get 4.65 times 10 to the 97. Because we're dealing with exponents, these can get really large quick. If you get one on the exam and it goes over 100, just put in 410 to the whatever this value is, and we'll deal with it that way. Okay, that's the only way I know how to do it. Okay, so if you go over 100 on your calculators, you might end up with 10 to the 120.56. Your calculator can't handle it, and you just leave it like that. All right, another problem. Sorry about